Good afternoon, everybody. I'm Silvia Angelini. I'm a PhD student from the University of Bologna, and my PhD project is carried out in collaboration with Italian National Research Council and CSIRO from Australia. I'm talking about part of my PhD, that is a preliminary mice approach for European hake and Norway lobster inhabiting the Central Adriatic Sea. MICE stand for Model of Intermediate Complexity for Ecosystem Assessment, and they are a useful tool to produce an ecosystem-based fisheries management. The aim of this approach, as listed in Piqui et al. 2004, are avoid the degradation of the ecosystem, minimize the risk of irreversible change, obtain and maintain long-term socioeconomic benefit without compromising the ecosystem, generate knowledge about the modifying human action on the ecosystem process. To reach this purpose, different ecosystem models are available. Considering the complexity of this ecosystem, they can be classified in a wall of ecosystem model that include all the trophic level of the ecosystem considered. At the lower scale, we have extended single species assessment model that include the current single species assessment model with some information of the species considered. And the medium level, we have mice model that include just a limited number of species, and they address a specific question. In particular, mice models are characterized by they are useful to produce tactical decisions. They have an intermediate level of complexity. They answer specific management questions. They are question and data driven. They focus on a subset of the ecosystem. They account for major uncertainties. And they can include environmental and human components. My study area is part of the Central Adriatic Sea, and this is located in Northeast Mediterranean Sea. It is a particular area because it is a transition zone between the North and the South Adriatic. It hosts a distinctive stock of Norway lobster characterized by a small size individual, and it is a nursery ground for hake. Moreover, the particular circulation of Adriatic Sea retain in this area a lot of nutrient and larvae that make this area an important fishing ground for Croatian and Italian vessels. The target species of this study are hake and Norway lobster. As you can see, they are particularly concentrated in the Central Adriatic Sea. And the graph shows the Italian landings for the North and Central Adriatic Sea. They describe a worrying situation because they decrease over the year, in particular for hake, that underline the need of management measures both for this species and for the ecosystem more in general. Starting to the target species, a conceptual mice model was built. The target species were separated in adult and juvenile to better understand the trophic level and of the species and to underline a cannibalistic relationship. Other prey items were separated in 5 groups. Starting from right, we have a crustacean group 1 that include bentopelagic species, and basically the only predator for this group is juvenile hake. Then we have cephalopods group. Then we have fish group 2 that it mainly constituted by demersal species as blue whiting and poor cod. Another fish group is fish group 1 that include pelagic species as anchovy and bog. The last group is benthic crustacean species that form the crustacean group 2. All these functional groups, except for crustacean group 1, are affected by fishing activity. The starting point of the mice model is a single species stock assessment. We did a length cohort analysis for both the target species. We used the length cohort analysis because the age determination for hake and Norway lobster are not available, and also because the time series considered are quite short. As you can see in the graph, the exploited population for hake is constituted mainly by juvenile species, since a big proportion of this exploited stock are under the minimum landing size. Opposite is the situation for Norway lobster, but the number of length beans are less than those for hake. Natural mortality was estimated using a probiome for hake, and we took a value from literature for Norway lobster. Terminal fishing mortality is 0.6 for hake and 0.3 for Norway lobster. We did a VIT run for each year of the time series considered, and here you can see the result. The biomass of this species is decreasing over the year, in particular for hake. To investigate the future of this stock and which management measure can be used, we made a single species projection model. We use a length-based transition matrix that describe the number of individuals that can move from a length beans to another length beans. And to estimate the population number, we use this equation. Then, using this model, we simulate different scenarios. First, a base case model. We started from the situation that we found in 2011, and we projected for 10 years, for 10 years this stock without the fishing mortality. We can see that the stock are increasing to reach a stable level. This is particularly true for Norway lobster. Then we had fishing mortality and variability, and recruitment variability. In the left part of both boxes, we can see that the population are a little bit increasing, but without particular recovery. Then we tested a decrease in recruitment of 50%, and it is the right part of both boxes, and the stock decreasing really steep. Regarding the prey groups, as I illustrated before, first we define common prey groups. Then we estimate the biomass for the studied area using a scientific survey done in the Central Adriatic Sea. Growth parameters for prey groups were defined. These values come from mainly fish base, and where the species is absent, we use literature from the Mediterranean Sea. These values were particularly useful to estimate the intrinsic rate of increase for each prey groups that describe how this population grows. Then, knowing the stomach content, the stomach content considers the proportion of the prey in this stomach content, we use Dirichlet distribution to estimate the prey preference probability. In this box, we can see that the favored prey is benthic crustacea, followed by pelagic species. Finally, we can put all together this information, and the mice model was built. Basically, the two equations used for the mice model are the first one that estimate that model the predator functional response, and it estimates the consumption of prey group for each predator group. And with this equation, we model the Olin type 2 and 3. Then we we use this simple biomass dynamic model for each prey group. This equation covers the reproductive, functional, predator density consumption and harvest dynamic of each prey group. After that, we put together predator and prey dynamics, and we project it for 10 years. For 10 years. Using this methodology, we can test these different management scenarios. The first one, a base case, that is the continuation of the present situation. And we can see that the stock of hake and Norway lobster are mainly constituted by individuals of small length classes. The situation for the spawning stock biomass is more or less stable over the year, while prey groups are increasing over the year, in particular for those groups where commercial catches are absent or very low, as CG1. Then we saw what happened if we decrease the recruitment of 50%, and we saw that the abundance of this stock are decreasing, and this fact is particularly important for the spawning stock biomass that decrease steeply for both stocks. What we can do, what can increase the net selectivities, we simulate this scenario, decreasing the fishing mortality for the first land classes, and we can see that the first land classes are a little bit better than before. And in particular, spawning stock biomass is increasing for hake to 2004 and then decrease, while for Norway lobster there is a particular benefit. Regarding prey groups, more or less we can see the same situation that I showed before. Finally, we tested the extension of the fishing closure. For this area, we have already a period of fishing closure that is more or less 1 month or of 40 days each year during the summertime. Increasing this period, and we simulated as these scenarios, decreasing the fishing mortality all over the length classes, we can see that the spawning stock biomass have a lot of benefit, both for hake and Norway lobster, since they increase until 2014 for hake and 2013 for Norway lobster. After that, they decrease, but less than before. So we can conclude that the Central Adriatic Sea is an important area for the entire Adriatic ecosystem because it's full of species. Considering the result of the single species stock assessment and the trend of the prey group that are decreasing as the single species assessment show, an ecosystem approach to fisheries is needed. And at the moment, the most meaningful management measure is the extension of the fishing closure. The future development of this work are improved single species stock assessment using a statistical catch age or length, include environmental variables as temperature or oxygen, explicitly represent discard in the model and the effect of their regulation, and expand the study area to the entire GSA 17, that is all the northern Central Adriatic Sea. Thank you for your attention.